The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video: Square Root of 6-digit numbers with 3 decimal digits. Example: 186,834. Now let us set the number in the right extreme of the abacus. That is, leave 3 columns at the extreme right of the abacus and set 4 in the thousands column, and 3 to the left of 4, and 8 to the left of 3, 6 to the left of 8, and 8 to the left of 6, and finally 1 to the left of 8. For the purpose of calculation, we can consider the groups in order as 18, 68 and 34. Take the first group 18 and consider the perfect squares there. You have 4, 9 and 16 as the 3 perfect squares. Now 16 is the highest perfect square and take the square root 4. Set the 4 to the immediate left of 18 and subtract 16 from 18. Now you are left with 26,834. In the next stage, double the number 4 and set 8 in the extreme left of the abacus. Consider 26 of 268, which in fact is the combination of the remainder of the first group and the second group. Now ask how many 8s in 26? You get the answer as 3. In the case of small numbers, you need not have to go for assumed quotient. Therefore, straight away set the number 3 to the right of the first digit of the square root and to the right side of the number 8, which is set in the extreme left of the abacus. Now multiply 3 with 83. That is, 3 multiplied with 8 is 24. That should be subtracted from 26, which gives the remainder as 28. Now 3 multiplied with 3 is 9. That should be subtracted from 28. That gives you 19. Now you are left with 1934. Look at the square root now. In the square root section, we have 43. That should be doubled, and therefore clear 83 and set 86 in the left extreme. Now consider 86 and 1934. Look at the first digit of the dividend and the divisor. Here also you get small numbers. Ask how many 8s in 19? By saying 2, set 2 to the right of 43 and to the right of 86. Multiply 2 with 862 and subtract that from 1934. That is, 2 is multiplied with 8 and 16 should be subtracted from 19, and the remainder is 334. Now multiply 2 with 6, which is 12, and therefore subtract 12 from 33. Now you are left with 214. Multiply 2 with 2, which is 4. That should be subtracted from 4, and you are left with 210. Now you have to go for your decimal part of the square root. Add one more 0 to the dividend 210. That will make it as 2100. From here on, you can simply follow the regular division procedures in getting the decimal part of the square root. For getting the divisor, you can double the square root 432, which is 864. As there are 2 8s in 21, set that as the first digit of the decimal part of the square root, that is 432.2. Set the 2 to the right of 432 and multiply the same with 864, which is 1728. That should be subtracted from 2100 and you will get the remainder as 372. The remainder is 372. Now add 0 to this number to get the second decimal digit of the square root. When we are going to the second decimal of the square root, you can round off the divisor and get approximate values. 864 is closer to 900 and therefore you ask how many 900s in 3720. By saying 4, you place the 4 to the right of the present square root, that is 432.2, and you get 432.24. Now multiply 4 with 864, that is 3456, and subtract this from 3720 and you get 264 as the remainder. Now we are going for the third decimal digit of the square root. Therefore add 0 to the remainder 264 and that becomes 2640. Now look at the divisor, again round it off, that becomes 900, and then you ask how many 900s in 2640 and take 2 as the third decimal digit of the square root. Now subtract 2 multiplied with 864, which is 1728. Subtract it from 2640, that gives you a value of 912. Now we have to go for correction with the third decimal digit. Let us look at the remainder 912, which is higher than the midpoint 432 of the divisor 864. Therefore, the decimal part of the square root may be rounded off to 432.243. Again, we have to note that when we are doing the problems, though there are more columns occupied with the beads, the calculation never ran into different sections, though they are appearing in the adjacent sections also. Therefore, careful handling of the abacus beads, even in the higher level calculation involving a square root, will always give the right result. Therefore, placement of the right bead in the right column in the abacus is absolutely important.